Alright, so here we're going to solve by completing the square. It's another review for the test that was requested, so let's just start. If we complete the square, we need to make sure that this term, the A term, is equal to 1, and it is. And if it is, then we can start by isolating our constant. So we're going to add the 35 to each side. So we have all variables one side, all constants on the other. R squared minus 2r equals 35. From here, we need to take our b over 2 and square it. So we have negative 2 as our b, divide that by 2, and square it. So it's negative 1 squared, which is 1. R squared minus 2r plus 1 equals 35, and you add this constant to both sides, so plus 1 as well. Here we have a perfect square trinomial, so let's factor that out. So it's r minus 1 squared. This term over here is always going to be b over 2. So you see our b over 2 is negative 1. That's always going to be b over 2 is negative 1 in this case. And 35 plus 1 is 36. So now we can take the square root of both sides. And this is nice to have a perfect square over here. So we get r minus 1. This is very similar to a solving by square root problem right here. It actually is using the same method. And equals plus or minus 6. So we can add 1 to both sides. So now we have a couple options for r. R either equals 1, it's 1 plus or minus 6. So that's r equals 1 plus 6, or r equals 1 minus 6. So our two options are 7 and negative 5. And that's how we solve a fairly simple problem by completing the square. So just remember that this is b over 2. You add the b over 2 squared to both sides before that. Then you just use the square root and then plus or minus for your answers. So let's move on to a little trickier problem. This one's nice because they've already isolated our constant, but the problem is that our a is not equal to 1. So let's divide everything by 3. You're dividing every term by whatever your leading coefficient is. So if this was a 7, you'd have to divide everything by 7, even though it doesn't necessarily go in evenly. So we'll get x squared plus 4x equals 8. Now we have 4 over 2. That's our b over 2, and we have to square it. So b over 2 becomes 2 squared, which is 4. This is what we'll end up adding for our two binomials when it's like x plus 2 squared. So we'll have x squared plus 4x plus 4 equals 8 plus 4, right? We add that to both sides. This is a nice one because we're going to have to simplify a radical at the end. We're not going to have a perfect square. So we have x plus 2 squared when you simplify that perfect square trinomial, right? 2 is our b over 2 equals 12. Now we can take our square root, use the square root property. X plus 2 equals plus or minus radical 12, which we know we can take a perfect square out. We can take out radical 4 from radical 3, so that becomes x plus 2 equals plus or minus 2 radical 3. And from there, all we have to do is subtract the 2 over to get x alone. So x equals negative 2 plus or minus 2 radical 3. And that's how you complete the square if your a is not equal to 1. Everything else is pretty much the same after you divide that first term. So let's look at this last one. This one's going to create a couple issues for us. First, why don't we isolate our constants? It's halves over here, just make it a little more organized. So we're going to say 2x squared minus 15x equals 35. Now a does not equal 1, so we divide everything by 2. As you can all see, this is going to create some issues for us because these do not go in evenly. So we're going to be working with some fractions. X squared minus 15 over 2x equals 35 over 2. So in this case, our b over 2 is negative 15 over 2 divided by 2 squared, which is negative 15 over 4 squared. and that's just 225 over 16. And you don't want to simplify anything in here or here. Just wait until the end to simplify. It just makes things difficult when you have to deal with common denominators, when you're trying to simplify down and reduce everything. Just keep everything as big as you possibly can. So we have x squared minus 15 over 2x plus 225 over 16 equals 35 over 2 plus 225 over 16. The reason that's 16 is because we squared not only the top, but the bottom as well. So negative 15 squared is 225, 4 squared is 16. So now this we can simplify. We can take our x minus, since this is negative, and this is negative, b over 2 squared, but just the b over 2 for this part. X minus 15 over 4, square that. Now this side we have an issue. This is not a common denominator, so we need to multiply this by 8 and this by 8. So that would give us 71,280 over 16 plus 225 over 16. Okay, so now we can combine these like terms. We have x minus 15 over 4 squared equals 505 over 16. Take the square root of both sides. Take the square root. So x minus 15 over 4 equals plus or minus this nice creature. So let's try and figure out whatever perfect squares go into 505. And I'm trying all different odd numbers, and they're not really working out for me. So I'm going to guess that there are no perfect squares that go into 505. And that's fine. So we can simplify the bottom, we just can't simplify the top. So we'll get plus or minus radical 505 over 4. And these denominators should end up being the same if you're doing it right. So we have add the 15 over 4 over. X equals 15 over 4 plus or minus radical 505 over 4. And that's it. And that is about as hard as these get because of the fraction and just understanding that b over 2, how to divide the fraction correctly, how to make your common denominator, how to add the fractions, and simplify a large radical. So that's a review for completing the square.